Hey guys, welcome to virtual math class for the very last time. Oh my goodness, can you believe it is the last lesson of the year? I'm getting emotional, guys. Yeah, so we are gonna keep talking about algebra. We're gonna keep talking about dilations, and this time in this last little lesson, we're gonna do algebraic representations of dilations. Sounds harder than it is. For the last time, create your very last entry into your math notebook. Hit pause. So we're looking at algebraic representations of dilations. And we're going to look at how you can describe the effects of a dilation with algebraic representation. And before I forget, don't get rid of your math notebook. You're going to want it for Mr. Bauer's class. You're going to use a different one for his class, but a lot of the assessments that you're going to take at different points in time, or like when you're reviewing for state tests, if we have to do that next year, whatever, you're going to want to look back on your notebook with all your 7th and 8th grade stuff, because it'll help you with the high school math that you're now pretty much ready for. So don't throw it in the middle of the yard and light it on fire and dance around it. Okay, just hold on to it, stick it in your backpack. You're gonna thank me, because you're gonna want it next year, trust me. All right. So enlargements. If it gets bigger, it's an enlargement. If it gets smaller, it's a reduction. And I looked at a few in the last lesson, and we noticed that if we had a bigger number, the number got bigger, and if we had a smaller number that was less than 1, that gave us a reduction. So maybe you noticed that, maybe you didn't, but here you go. So go ahead and hit pause, copy this down. All right, so we're going to call that scale factor that we found in the last lesson, we're going to call it k. And the algebraic representations are pretty darn easy. We're just going to multiply each x and y coordinate by that scale factor, by that k. And enlargements are any number bigger than 1. Reductions are between 0 and 1. If 0 was our scale factor, that would just make it disappear. If 1 was our scale factor, we wouldn't do anything to it at all. It would just stay the same. As a matter of fact, if you've ever used a copy machine before and played around with enlargements or reductions, it has you enter in a scale factor in the form of a percent, but it's the same thing. If I want to make something bigger on the copy machine, I'm going to turn it to 150% or something like that, which would be a 1.5. Or if I want to make it smaller, maybe I go down to 75%, which would be 0.75. And that's going to give me either an enlargement or a reduction. All right, this is a little check for understanding. So I want you to copy down this chart, and I want you to try to fill it in. And then you can hit pause, then you can unpause it and check your answer against me. Okay? Hit pause, copy it down, try to complete the chart. Okay, so how'd you do? If the scale factor is 4, then my algebraic representation is going to be 4x comma 4y. If it's a 0.5 here in front of them, that means that's my scale factor. It can also be written as a fraction. So over here, if it's 3/4, it would be 3/4 x or 3/4 y, or you could change it to a decimal. You don't have to, though. And then here, if I have a 2 in front of these, hey, that means my scale factor is 2. So hopefully you figured that out. If not, don't worry about it. Just hit pause and copy it in. Okay, so here's the steps for graphing a dilation. So hit pause, copy them down. So basically we're going to make a little, I call it a PI table. Okay, a little simpler than the ones we were using in the previous lessons, just really stripped down because it's pretty easy. We're going to put the pre-image coordinate over here, I don't know, 1, comma 1. We're going to multiply each of these by the scale factor. So if my scale factor was 3, then I'd multiply by 3, and I'd get my image of 3 over 3, like that. I'm going to use this T-chart to kind of keep it organized, and then I'm going to graph it. You don't need to write that down, though. That was just me talking and giving an example. All right, so I'm going to go ahead and do one here. I have this little diamond. I want to apply a dilation, and here is my rule. I can tell by looking at my rule that my scale factor must be 3 over 2, which is also 1.5. So here's my PI chart, okay, my little T-chart. So I'm going to put my pre-image on one side, copy them all down, and then I'm going to multiply by 3 over 2, or 1.5, to get my image over here. So the 0 is not going to change, right? But negative 2 times 1.5 is going to be negative 3. Same deal over here. And 2 times 1.5 is going to be 3. So there's all that. And then I'm going to graph it. So 3 comma 0 is going to be here. 0, negative 3, negative 3, 0, and 0, negative 3. And then, oh man, you can watch me struggle to connect the dots one last time. Boy, I missed my smart board. And there you go, kind of. I enlarged it by 1.5. Aren't you impressed? Okay. I want you to play along with me. Okay? So I want you to, on a piece of scratch paper, do the PI part. You're not going to be able to easily graph it, but you're going to do the PI part. So grab your piece of scratch paper. You're going to list every coordinate, so we'll start with I over here. Okay? So we're going to go 2, 4, for example. You're going to apply a scale factor of 1.5, so that means you're going to multiply each one to get I prime by multiplying it by 1.5. So then we're going to get 3, 6. Yeah. Okay? Like that. All right, so go ahead and hit pause, work both problems. Okay? Give it a try. Come back when you have your little PI tables done. And then we'll graph them and see how we did. Pause, pause, pause. Don't cheat. All right, before I graph them, I want you to check in on how you did. So you should have listed all these pre-image coordinates and gotten this for your image. And same over here. Pre-image, image. Okay? So pause, look them over, compare, and then hit play again, and I'll show you the graphed version. So how'd you do? Hopefully you got what I got. Minus maybe a small mistake. And when I graph them, I see what I expect. So I know from my scale factor, since it's greater than 1, it's an enlargement. And so my image here is an enlargement, and it looks to be 1.5 times bigger, right? And then over here, because it is less than 1, I know it's a reduction. So I get a teeny tiny little triangle. That's about 1/3 the size of this triangle right here. All right, so I'm going easy on you by making it a super short lesson, but I want you to create your own summary here. So talk about scale factor and how you know if it's like an enlargement or a reduction, and how you would go about graphing them. Okay, one last summary for the year. You can do it, I swear. So hit pause, give it a try, and then I have one last cheesy math video. Okay, well, I tried to play that video twice, and the sound was messed up both times. So I will post a link to it with the Google Classroom assignment, and that's why you see it now sitting off to the side, so you can enjoy the cheesy math video. Sorry about that. But yeah, it's been a year, guys. I'm really sad that we couldn't finish it the way that we were supposed to, but it is what it is, and thank you for coming on this journey with me. And the vast majority of you showed up, watched the lessons, took notes, and I really, really appreciate that. I really appreciated that you took the time to value your education and keep going under these weird circumstances. And so that gave me the energy and enthusiasm to also keep going. And yeah, guys, so I'm a little sad, but I'm also happy to not just talk to my computer screen all day. So anyways, hold on to that math notebook. You're going to want it from Mr. Bauer's class, and I now deem you ready for high school math. It's not as scary as it sounds. You will survive. All right, guys, stay safe, and give me an air high five when you see me next year. All right? Bye. Happy summer.